All right, guys, we're going to continue. This is the second half of today. So I'm going to go ahead and share the screen here. All right, so we're back. So today we're discussing, as I said, collecting data, right? This is part 2 video. So we've done collecting data from HTML, and then we finished up RSS, right? So we did this one over here. And there we go. We've got some RSS feeds. Right, so you can see, virtual panel discussion with Lilly CEO to highlight 50 Lilly Day Purdue. All right. So again, you can token. Oh, so now what we would need to do is same thing as before, right? So remember that the homework assignment is going to require for you guys to create the frequency plots, right, as we did this one. So we would call this one again. So basically, I guess, get rid of that. So we need to calculate the tokens. We're going to tokenize raw2, and raw2 will be, we're going to remove any new line characters from it, replace them with spaces. And then we just need to, but we need to create a new raw, right? That's the only thing. So now our raw won't be the old HTML, it'll be this one. So the way to do it should be simple. Raw equals nothing, right? And then we're just going to add this into raw every time, right? Annex it into it. So we can probably do raw equal raw plus, and we just concatenate post dot title, right? So that should be the idea. Let's see if that works. All right, that worked. So let's see now if the data is correct. Yep, I can see the word Purdue in there. You see that? So that basically tells me that this plot is actually in relation to the Purdue RSS feeds. It says there Purdue theater, locations, university, speak, choir. I remember that one about the choir. 2021, Martin. However, if I look at this, I would say that it's not filtered good enough. You guys see that? My judgment on this one is, see, it's got periods, 2 of, parentheses. You need to, there's an S in there. So you guys, in your homework assignment, as part of your homework assignment, you need to clean this up further. Okay, use better filters, play with it a little bit more. Got it? All right. Yeah, go ahead, please. So you want RSS as well as HTML? Yes. I will write a Word document for this, or not, put it in the assignment link. But yes, I want 5 websites, 5 RSS, and 5 Twitter collections. Yeah. So maybe the Twitter homework will be a second homework because I don't think we'll have time for that one today, and it's actually much more involved. But at least for this week, what's due next Monday, it'll just be 5 websites and 5 RSS feeds. Yes. And just keep in mind, you're already practicing what you're going to do in part B of your project. Any other questions, guys? Okay. So let me just make sure. Maybe I want to do some more examples of filtering. Let me just see, just to kind of illustrate what else you can do. Let's see if I can find anything interesting in here. Yeah, so one filter actually that I won't demo, but I'll give you a kind of a hint, is that sometimes you get, I mean, Beautiful Soup actually does a great job nowadays, so you may not even need this. Used to be, though, that, let's see, we're filtering part. No. Here, let's add a new filter. So it used to be that you would go to some websites and you would get a lot of non-ASCII characters, Unicode types of things. And they would look like hexadecimal or whatever. So if the strings that you're finding in your websites has non-ASCII characters, you might want to remove them. Although, as I said, this is all almost built in nowadays, it seems. But I'll just do an example here. So I'll do raw 3. Right, and then you can use so you're going to need to import the regular expression module. So I'm going to do over here. So I'm going to do import RE, that stands for regular expression. So it's something that allows you to look up things by a regular expression and then do a replace. So in this case, you can use the built-in function re dot, and then sub for substitution. And then here, usually then you can say what you're looking for and what you're replacing it with. So you have to use the character R, single quote, then you specify the regular expression. So in this case, you put it in square brackets, and this is just, you can just use this one, right? This is for finding Unicodes and getting rid of them. So it's basically caret x 0, 0, 2. So this is a range to x 7f. So it's basically like filter out all the range of these hexadecimal values from 0, 0 to 7f. Okay. So do that. Right, so that's what you're looking for, and then you replace it with R, single quotes with nothing. That's equivalent to like, space or nothing, and then just plug in here raw, whatever it is that you're, the input basically. Does this make sense, guys? So this is another example. I don't even think you'll need it, but just wanted to illustrate that you could do this. Let's just run the code to make sure it'll run. Okay. Should be this. After the F bracket. Oh yeah, good eye. Yeah, you're right. Good eye. Good catch. Thank you. Yeah, so let's try it again. Perfect, and it works. You guys see that? So certainly, you can try that one. That's just, for removing, as I said, if you find any, like if you start seeing a lot of hexadecimal values, right? It's probably that it's Unicode. Just get rid of that with this. Although, as I said, Beautiful Soup seems to be doing a good job with that as well. I'll comment that out though. but we know it works. All right. So that's one filter that's usually useful. And then after that, I mean, it's obvious, but you may just need to do something like this. So this one I'm just gonna do as a comment, raw 7 equal, raw 5, whatever, dot replace. And you need to replace specific characters that for this assignment, you really don't need, like, semicolon, right, or whatever. So you can just get rid of them and either put in a space or put in nothing. So that should be pretty straightforward. Yeah, so basically anything that you find in there that's ending up in your chart, in your little graph, and doesn't provide any semantic meaning, you can get rid of it with this approach. So that should do it. Tabs, remember, are \T. So you can try those as well. So I think that's all the main ones. For the main logic, I guess. Yeah. All right. So, and then this is Twitter. We'll talk about that. All right. So we're basically done. So Twitter, I'm gonna hold that off until next Monday. It'll be a second homework. Or another homework. So now let's go back to, let's kind of analyze where we are, right? So we can do this, right? This is the pipeline for the homework. So basically that means that we collect the data, we scrape. Remember, that's the keyword. We're scraping data from either, and that's, it's called data scraping, data wrangling, right? That's what we're doing right now. So you grab the data from an HTML, you grab the data from an RSS feed. Those are the two things that we know about. Get rid of all the HTML, end up with some strings, and now we have one big string and we can tokenize it, right? And tokenizing it allows us to view it and do some kind of data analysis. Now we want to take it even a step further and do machine learning for it, right? That means we need to do, we want to convert it to the vector space model. Okay, so that's the next step that we need to address right now. Let me just grab my tablet tool. All right, so let's go to the whiteboard. And remember, this is the pipeline that you want to try to memorize or understand really well. We collect some data. So scraping. So scraping the data, that means going to the internet. You're going to draw it as the cloud, the web. Right, and in here we have HTML, we have RSS, have Twitter and other social media, right, and so on, right? So we are grabbing our data from here, and we initially just download it as, some kind of text, right? But we would need to apply, lots of filters. That's what we've been looking, right? So that's what we did. Now we have, at this point, let's imagine we just have a lot of text, all the text in here, and it could be pretty large, just basically separate it a little bit. Now, if we want to do machine learning over here, right, and in particular, like supervised learning, we need a data set, right? We need a data set. So a lot of the things that whenever you did machine learning so far, you have used PyTorch, right? Or you have used Weka now, you know how to use Weka as well, right? And always you need some kind of a data set, right? So you need the data set. All right, and the data set is the next step here, right? So this is what I usually call the vector space model, okay? Which basically means you need to take your data here, which is totally unstructured, and you need to run it through the vector space model approach to end up with data sets that look like what? They look like Cyfar 10, right? They look like MNIST. They look like Iris. That's why you should always make a reference in particular to these two, right? Because if you have MNIST and Iris, it's going to load into Weka automatically. If you have MNIST and Iris, convert it into a specific tensor, and it'll load into PyTorch. Do you guys see that? So that's the approach. So now we have to, over here, now we have over here to focus on converting to the vector space model. Okay, now the vector space model is a specific approach, right? It means this, right? Whole bunch of dimensions, all intuitively 90 degrees from each other. That's called orthogonal, and what that means is that they're independent, right? You can't cast a shadow of one on the other, right? So because they're completely parallel like that. And so this is the vector space model. So remember that every one of these is a feature. So for instance, iris data, Fisher's iris, what does it look like? How many samples does Iris Fisher have? 150, right? So it's got 100, 1, 2, 3, 4, all the way to 150. What is every sample in Iris Fisher data set? What is every sample? It's an observation of a plant, right? Of a little tree or something. So each one of these samples is an observation of a plant. Okay. How many features does the iris data have? 4, exactly. It's got 4, X1, X2, X3, X4. What are those features? They're just basically information about the length, the width of the petals or something like that, right? There's 4. This is the X data. What else do you need for supervised learning? The Y data. It's a separate vector of the same dimensions, 150, but you only have the labels, right? So this is the Y data. What are the labels for iris? There's 3 of them, right? Setosa, Virginica, and versicolor. So 0, 0, 1, 1, 2, 2, 1. Okay, so that's basically, this is, whenever you're lost or confused or whatever it is, go back to iris. Always go back to iris, also to MNIST. Use them as reference because that's what I need my data to look like. It needs to look like iris. It needs to look like MNIST. I can load it into Weka and complete the pipeline really quickly by doing it. Then I can advance. I know it works in Weka. Now I can do it in PyTorch by taking the next step of converting my data into a tensor. And then I build all of my neural nets. So the key thing is Now you have to do this, but for the data that you're collecting, right? Your HTML data. So you have to convert, both of these are the same, right? So this has 4. So then this should have 4. So I'm going to go ahead and just remove 1. Actually, the other one. And basically it should have a 4th one. F3. And then this should be F4. All right, so it's a vector space. Each feature, the F is actually, so X, right? So X, 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 X. All right, so that's what they are. All right, so how do we do that? Here is the challenge, right? We need to, in the vector space model, we need to take our unstructured data and convert it into that representation. Now, this can be further divided into 2 things, right? So obviously you need to figure out what these features are going to be, because they're not going to be width and length of plants when we're talking about text that we got from HTML or CSS. So we need to kind of decide what we want these to be. And then once we know what we want these to be, we need to find an algorithm that will give us that. Okay, so that's really the part of it. So usually here, the simplest approach is to create what is called a bag of words approach. But I'll give you actually 2 techniques that exist. We're only going to cover 1. So let's say that we have a lot of data. We have a ton of data that we've collected, let's say from Twitter. So many tweets of text, right? And we want to convert them into the vector space model. There are at least 2 main approaches: the bag of words approach and something called word to vec. Both of them will give us a data set that looks like iris. Both of them will give us exactly that, at least the X part. We don't have the labels yet, because that's another problem, but at least the X data. But we need to decide, what do we want the samples to be? So in this case, since we're doing Twitter data, it's going to be a tweet. So every tweet we're going to decide is a sample. So this is what the matrix would look like, X. This is what the matrix would look like, X. Right? The samples, each one, I'm going to use the letter T or TW to designate tweet. So tweet 1, tweet 2, tweet 3, ... all the way to tweet N. You guys know what a tweet is, right? What is a tweet? Just tweet. So in Twitter, it's basically like, let's say 100 words, right? I don't know the exact number, but let's say 100 words that you can say whatever you want. And that's a unit. And then you want to say something else, you say another 100-word tweet and whatever. So it's like a sentence in a document, right? So every sentence is a separate thing. So over here, then, we've agreed that the tweets are the samples. That's what's important about this. You got to convert every tweet or every sentence or every RSS feed, whatever it is, into a sample. And now you need to represent it by the features, right? So you need to represent each one by the features. So in the bag of words approach, basically we say words are columns or features, right? So we say the, car, hat, blue, and so on. However, how many words are there in the English language? How many words? Who can tell me? How many words on average get used? in a vocabulary. Maybe not how many there are in total, but how many get used on average in conversation. Like college students, how many words do you think you? Probably not talking about, poetry, right? So what would be the words that you use? Well, what would be in particular, what is the size of that vocabulary? Just give me a guess. 20,000, right? So it's a good number, right? So then if it's 20,000, now we just learned that we can calculate frequency of words, right? We can rank them and get the most frequent words, right? So let's say that you say 20,000, but that includes the, and other things. Get rid of those words that don't provide any meaning and arrive at 10,000. So 10 out of the 20,000, calculate frequencies, rank it, and select the 10,000 most frequent. Do you see that? So why is that relevant? Because that determines the size of this vector to be 10,000 words, the most frequent ones. And then after that, for every tweet, let's say tweet 2, we decide, okay, the car, how many times does car appear? 1. How many times does hat appear? 0. How many times does blue appear? For whatever reason, 3 times, right? You see that? And you kind of do that for every single one. But this ends up being, what's the size of this matrix? Well, let's say you have 100,000 tweets. So what would end up being the dimensions of this matrix? 100,000 by 10,000. Do you see that, guys? And it's going to end up being what is called a sparse matrix, which basically means most of the values in this matrix are 0. Did you guys notice that? Think about that. You have a tweet, right, which only has 100 words, right, at most. You have a vector of 10,000 words. So imagine out of those 10,000 in this vector, less than 100 are going to have a value. The rest are just going to be 0. Does that make sense, guys? That's called the bag of words approach. It is not the best one. Another approach is this word-to-vec. Word-to-vec is something that we will cover in the deep learning class, not in this one. All right, so this is one of the more advanced algorithms for the DL class. But basically, what does word-to-vec do? Word-to-vec has an algorithm which was finalized in 2014 by Mikolov from Google. And they basically decided, I don't like matrices that are 10,000 or 100,000 by 10,000. And in particular, because all the values inside, the majority are 0. That's tough for a machine learning algorithm to learn like that. Although it can, it's tough. So they decided, you know what? Can we find a way to do this differently? And so what they came up with is and I'm just going to give you the intuition here, is that they found out a way to just set the vector space. So they decided, you know what, we're going to just decide the size of this at 128. The vector, the features here, x1, x2, all the way to x128, are no longer the words. They're not words. Okay? There is a complicated algorithm that we will study in deep learning that basically, through that algorithm and looking at the words, we look at the co-occurrence of words. That is to say, how 2 words occur together, right? So if you see, for instance, Paris, France, Berlin, Germany, Mexico, Washington, What is the conclusion? Again, Paris, France, Berlin, Germany, Washington, USA, right? You guys were able to discern or conclude that, right? You saw a pattern. So Mikolov reversed that, figured out the algorithm for that, and that's what they try to do in the algorithm. And then they say they create just 128 features, and basically a feature might end up being like, something else, some other meaning, right? And it's going to, for instance, you know, this tweet talks about capital cities. That might be X2. So if that's X2, how much does it talk about it? A lot or little? And it kind of puts a weight in there. You see that? So what we end up with is, instead of a matrix that has a lot of zeros, we end up with a matrix that has all values here. You see, and the dimension of it is 100,000 by 128. You see that much better. It's much better because it's much smaller, and it's much better because this one is all zeros, this one is all values. Okay, what usually, the way to achieve this usually is that you use the word2vec algorithm. Okay, so in this, so definitely today I don't want to get into the word2vec algorithm. If you want to learn about the word2vec algorithm, as I said, take the deep learning class. We will also there in that class learn how to get it. But what's important about it is there's an algorithm involved. So now let's do the same here. So let's say that I have my data set, right? All the HTML data, all the RSS feeds, and whatever, Twitter, and so on. I want to end up with a vector space model of 100,000 tweets by either 10,000, which is the bag of words approach, or 128 dimensions, which is word2vec. What do I need? I need code, an algorithm, okay? So with so the algorithms are gonna be 1 and 2, the bag of words approach or word2vec. By the way, word2vec is only one of several. There's several algorithms. Word2vec is just the one that Google came up with first. Facebook came up with another one. You know. So anyway, you would take the data, feed it through these algorithms. The algorithms produce these. If you look at these two, they are now ready to be loaded into Weka, for instance, because Weka is very forgiving. And they don't have labels. They don't do magic, right? So they only create the X. Okay, but you know that is the process. That's called, you know, that's what we want to do, create the vector space model. It depends on what we want to do. Okay, guys? So today, so hopefully this makes sense. So obviously in this class, we're just focusing on the most basic stuff. So we're going to do the bag of words approach, bow, and we're not going to cover word2vec in the course, but it's pretty straightforward. Word2vec is a script in Python. You give it all of this as one text file. So basically how we have our text files right now, and it's going to produce this one. You know, it'll give you a text file, which will have each sample and 128 columns. And the columns, remember, are not the words. Instead, it just learns a space. You just define, basically, the way that you do it is you define a space of 128 dimensions because you set it that way. And you say, look at all these words and how they occur, find patterns in them, and represent them in that space. Okay, so every word, every word actually in the space is a point. So in word2vec actually, where you have 128 dimensions, you know, R128, every word is a point. So for instance, Paris is over here, then France is over there. You see that? And then over here, let's say, oh, what was it? Canada. What's the capital of Canada? Ottawa? Ottawa? Yeah. Ottawa, right? Do you see? So apparently, Mikolov actually discovered something. Do you see that? So let me give you one more example, I guess. You know, what is the capital of China? Beijing, right? So Beijing. Do you see that? Okay, so now I'm going to do the following. You guys are much, you know, you're AIs, right? Find the pattern here. What's the pattern in this picture? What's the pattern? Do you see a pattern? What is it? Right? Do you see that? So apparently Word2Vec even captures this. It captures a certain dimensionality about the data. So if you were to use this, what would you conclude about where would Washington, D.C. be on this map? You just take the same vector, right? So DC, Washington, D.C. would be there. And so it allows you to infer even things like, you know, what is the capital of Colombia, right? So what is the capital of Colombia? So if you find Colombia, what would you do based on this approach? Project that same arrow, find all the words there. One of them could be, I think it's Bogota, the capital of Colombia. Does that make sense, guys? That's what Word2Vec supposedly can do. All right, so it's a really nice algorithm. As I said, it would take us a long time to get into the algorithm, to the specifics of it. It's not trivial by any means, but it's approachable too. And so it's very powerful stuff. So this is also, I should say, this is why you want to learn deep learning, like more advanced, because we're just starting here with the basics. This is like, you know, new stuff. And this is actually old at this point. There's even more impressive things going on. Anyway, so going back. Yeah. So anyway, so our goal here is still, we're trying to understand the vector space model, right? So we've collected our data. We know how to clean it and filter it. Now we know that there's several advanced algorithms. There's many more. But we're going to just focus on the basic one, the bag of words approach. This will still give us this one, right? Downsides to this, a lot of zeros, very sparse. Also, too much dimensionality at 10,000. But this will be the approach that we're going to take. For those of you that feel like you want to experiment, you can try Word2Vec for your project. Right, for the project, but I won't ask any assignments with this. Okay, is that clear, guys? All right, good. So now let's go ahead and focus just on bag of words. So how can we do that? So in bag of words, the problem is we have our data, our string data, you know, some sentences, right? So let's say we have just sentences or tweets. And we're going to create, you know, a vector space model, which looks like that. Unfortunately, our R will be size n, where n is size of vocabulary of the most frequent words. And then this is going to give us our X data, which is a number of samples, n samples by basically n words. Because every n word is a feature. So it's going to be x1, x2, all the way to xn. All right, so that's the basic idea, right? So the quick way to do this, instead of doing this manually, now you had a homework assignment where you had to do this manually, right? So you have to at least think about it a little bit. So that was the point of that homework, just to get you all ready to understand the difficulty of it. In my next example, So we're going to switch back to the code and the time that we have left. So we're going to switch back to our code. We probably might want to create a new script. And we're going to do just that. So go ahead, think about it. All right, so let's actually create a new script. Let's do that. So I'm going to do. Let's call this one create a vector space model, right? So VSM from text.py. All right, so you guys can follow along. I'm going to use sklearn for this one. From sklearn. So we're going to say from sklearn, dot feature underscore extraction dot text import CountVectorizer. Okay. Let's also have NumPy handy just in case. Import NumPy as NP, which you guys already know how to use it because you've been playing with tensors all semester. So now let's create a data set. For this one, it's better to, in this example, I like to create a data set just because if we just use like raw data, we won't notice everything. Whereas if I'm just going to create a few sentences here. So I'm going to create sample or example, sorry. And I'm going to create a list. And in this list, I'm going to provide some sentences, right? So I'm going to say machine learning is super fun. That's one sentence. And another sentence will be Python is super cool. And add 7 sentences just so that we have enough data for this to work. Statistics is cool too. Then we can write another one. Data science is fun. Python is great for machine learning. Okay. So then we can say here, yeah, Python is great for machine learning. And then 2 more sentences. You can say, I like football. And finally, football is great to watch. All right, so I added 7 sentences. You guys, as intelligent beings, right? Can you see a pattern here? Can you group these 7 sentences into just 2 groups? What would be the 2 groups? What would they be? If you had to just give them like a label. Machine learning and sports, right? Yeah, exactly. Very good. So I intentionally have these 7 sentences to be that, because immediately humans look at them and come to that conclusion. Would you believe that a computer, not in the future, but right now, can already come to that conclusion? We can. We can actually, what is called, cluster the data. And you will see by the frequency of they're actually the words that are in there, they have a purpose. They're built in such a way that, I'll play with these words a little bit, but in a very simple way, we'll be able to arrive at that same conclusion that you did. So maybe that this reasoning that you were able to do is actually not such a complex thing after all, because a simple computer can also do that right now. You see that? So, maybe us as humans, we're not as sophisticated as we think. All right, so anyway, so this is a good example that I will do. This will cover actually bag of words, and then I'll use the same example to cover clustering. So it's actually a nice one. If we don't have time, this is, by the way, this is not part of the homework assignment. Remember, the homework assignment is just creating what? Those charts, right? So you have to do 5 for HTML, 5 for RSS. That's it. And I'll write it in the description. What I'm covering right now is just really important. I'm starting to think that I won't finish this today. We'll just continue it next week, and the Twitter part as well. But this is extremely important that you grasp this concept. Okay, so the first thing we want to do, so I have here, so let me just look. Yeah. All right, so I have here 7 sentences. These 7 sentences would be the equivalent of what we did in the first half of class today. We collected some RSS feeds, remember, from Purdue. So each one of those RSS feeds would be one of these sentences, right? Pretty straightforward. Or when we got the HTML, before we replaced the new line characters, remember we replaced those? Instead of doing that, we could have done a split on new line characters. That would have given us then basically every sentence. And we would have it exactly like this in a list. Got it? So that's what I want you to understand, that what I'm going to do right now, you could technically do on the RSS data, or you could do it on the HTML data. You would just, in RSS feed, what we did is a for loop, and then we printed out all the titles. Well, you could have just added those titles to a list. You would have exactly what you have. Is that clear for everyone? All right, perfect. So now that we have this example, what we want to do is we want to do the bag of words approach, right? Remember, I just explained that. BOW, bag of words approach. So we want to create a matrix that is samples by words. So this matrix, if every sentence is a sample, and let's say we're going to pick the 20 most frequent words from this vocabulary, what will be the dimensions of this matrix? The X data, what would be the dimensions of it? Every sentence is a sample, and I'm going to pick, let's say, the 10 most frequent words in the vocabulary. So what will be the dimensions? 7 by 10, right? Yeah, perfect. So 7 is the rows, the samples. 10 is the columns, the features, which are the words in this case, in bag of words. Very good. All right, perfect. If I wanted to use word2vec for this, it would be 7 by 128 if I define, the space as, but then we need to use the word2vec algorithm to figure it out. Today here, we're not going to write the algorithm for bag of words approach. I'm using just CountVectorizer because you've already thought about this problem in one of your homework assignments. All right, so then let's do the next part over here, which is to vectorize, right? And let me just get my extension. All right, so now let's do Vectorizer. Vectorizer. We're going to use CountVectorizer for this. Vectorizer. We're going to say that the words should appear in at least one sentence. So we're going to say min df equal 1. It must appear in at least one to be included. We're going to actually, this has a built-in function called stop words. And we just need to specify what language. So in this case, it's written in English. What stop words means is it's a list of words that are not usually useful semantically. For instance, the, to, that kind of thing. So those words usually can be filtered out because pretty much a lot of sentences have the word the in it. Not all of them, but a lot. And so it doesn't really provide much help. So this allows us to, get rid of them. So now we have Vectorizer. And then we're going to say data object Vectorizer dot fit and transform. What this means is, if you remember, we did something like this last week where we said fit does the training, transform then takes the model and applies it or something like that. Okay, so we do fit transform all at once, and we apply it to the data in example. And then the idea is that this will do the bag of words, applies the bag of words approach algorithm, and then it should give us our 7 by 10 or 7 by 20, depending on the number of most frequent words that we define. Got it? All right, so this is the idea. So let's go ahead. Now that we have the model here, we already have we've already done the processing. So let's print out some statistics here or some data. So let's say we want to print out from Vectorizer. So from Vectorizer, we're going to print the feature names. Okay, so Remember, this is 7 by the number of words that we have in there. So let's go ahead and run this part. I thought we installed this last week. Maybe we didn't. All right, it worked. Perfect. If you look at the output, what do you see? It gave us the words, right? In our vocabulary. Cool, data, football, fun, great. Leaning, I think I have a typo in there. It's probably learning. Like, machine, Python, science, statistics, super, you know, and so on, right? So I have these words in there. And those are going to be the features, the X's. So now it's either going to be, it's going to be a count. You know, how many times do I see that word in that particular sentence, right? So we want to take a look at that. So we're going to go back into our script. Now we want to view the data, right? We want to view the data. So I'm going to do print and I'm going to use pandas actually, because pandas is a tool that allows me to format things a little bit better. We'll probably have to install this one also. Okay, so import pandas as PD. And basically this one is just, as I said, it's a tool for formatting. So I'm going to create a panda.data frame. And I'm going to specify some things about this data frame. So I want to specify the rows, what should be in the rows and what should be in the columns, and what the data is, right? So what the data is. So the data is actually in DTM, right? So that's where my data is currently located. So DTM. And so I'm just going to say DTM, and I'm going to convert it to an array, because that's how pandas takes it, to an array. And then I'm going to specify what should appear in the like for the rows and for the columns, right? Like I'm setting up like headings for rows and headings for columns. So that to do that, we're going to say index is rows, and I'm going to assign to it what's in the list example. So it's just going to take the 7 sentences and kind of put them there in order. On the columns side, I'm going to say columns. And here, what do I want? The same thing actually that I did over here, right? The same thing. So the features. So I'm going to say then Vectorizer dot get feature names. Get feature names. Like that. Does this make sense, guys? So just putting in like labels. So now let's go ahead and print this one. Right, pandas is not there. Okay. Run it again. There you go. So in this case, oh, and I had that leaning in there. Let me change that. So now I'm going to run it. And it's not showing all the words, if you notice, right? So that's why it puts the little dot, dot, dot in. So notice that this is really nice because it shows machine learning is super fun, you know, all the sentences with the words in the column side, and then it's basically giving you the count of how many times it sees them in there, right? So for instance, machine learning is super fun. None of, you know, these are not there. Fun is there once, learning is once, machine is there once, right? Now for sentences that have Python is super, super cool, there's 2 occurrences of super. So you can see there's 2 for super. Notice it's very sparse though. Look, all of these are zeros. Look at how many zeros. Do you see that? Imagine, and this is here, it looks more dense because there's only a few words. Imagine when we selected 10,000 words, right? It's pure zeros, right? So obviously that's one of the downsides, and that kind of motivates why we want to use word2vec, the other algorithm I was talking about. But that, as I said, is for another class. So this is the vector space model. Through the algorithm of bag of words, we ended up with something that is represented as a vector of the words. Is this clear for everyone, guys? Does this make sense? This, you know, if there's one thing that I want you to learn in this class, is this. So it's extremely important that this is clear. Any questions? All right. Well, seems like you guys got it. All right. So that then now we have a data set, right? Now we have a data set. And so now comes the part. So if you think about it, now I ask you the question, is this in the same format as Iris to be used for machine learning? No labels currently, because that's a different problem. You know, first of all, we would want to figure out what the labels should be, right? We don't have them yet. But just in terms of X, not the Y, is this in the format of appropriate format like Iris? And if not, why not? Or maybe it is. It's binary here. Yeah, it's binary. Well, not binary actually, because it's count, right? So, but usually you won't have more than 4. Yeah, 1 and 2. So it's all numbers. Basically, what should be correct is the following, right? So now this is, let's say this word machine. That's feature, I don't know, X17 or something, right? For every one of the samples, you need to look to see if that X17 word occurs in it, right? In the same column. And then you're just going to mark 1 if it's there, or the count, and if not, a 0, right? So that's what should be correct, 100%, right? So it's basically like you're grabbing a feature and you're saying, is that present in the sample? What is the value of it? And that you record it. So yeah, so what I would say is this is a data set that is 7 by 13. You actually have the dimensions there. This matrix is ready for machine learning, for Weka, right? Or for, if we want to load it in PyTorch, we just have to take this. Maybe we would save this as a CSV, then take that CSV, load it into PyTorch, convert it into the tensors, and then we would feed it into a neural net. However, as you said, we don't have labels, right? We don't have labels. So that takes us to the other problem. What are the labels for this? What are the labels? How would you answer? I just asked you the question very in the exam. What are the labels for this? What are they? He said that for sure, but I could say how about sentences that talk about Python and sentences that don't talk about Python? Or I could take it even a step further. How about sentences that talk about sentences that are very excited and sentences that aren't that excited. You see what I'm saying? So he came up with one classification, potential classification, but there could be many more. And so the labels that we choose are going to depend on the problem that we're trying to solve. Do you see that? But yes, in this case, the obvious thing is to say what he said. Those are the, so then here the labels would be what? We need to create a new vector. What's your name, by the way? Alex. All right, so Alex's answer was, I want to label this based on the first thing that I noticed about it. And that is the first 5 are kind of data science-y. The last 2 are about sports. So then I'm going to create a new label where this is 0, 0, 0, 0, 0, 1, 1. Do you guys see that? And then now I have my labels in there. I have my Y vector. And now I can save my Y vector also into a text file or save it into the same CSV. And now I'm ready to do what we've been doing for the first half of the semester, converting that into tensors, doing the machine learning part. Got it, guys? Are there any questions about that? All right, great. So then we need to do that. Now that process of creating that vector manually is called annotation. Okay, and it's done by a human. Remember that in machine learning, what the computer learns is it learns to imitate the human. So Alex, in this case, if you annotated this 5 zeros and then 2 ones, right? That model that we feed into the deep learning or whatever, the algorithm would learn to think like you because you annotated it that way. Maybe when Liang looks at this and says, for whatever reason, yeah, the last 2 are sports, but I like statistics so much that to me it's a sport. And he just, you know, it's a sport to him for whatever reason, right? And so now 4 and 3. Do you see that? It's not wrong. It's just that's how he thinks. So the machine learning algorithm will grab that data and will start to learn that as opposed to that over there. You guys see that? So that's an important assumption. So manually, we can create the data set over here. In the next class, we will look at, because we won't have time to finish this code. So in the next class then, remember this, please. We're going to pick up here, and then we're going to see, okay, you know, can cluster, I should say, can the algorithm kind of infer those things as well, those labels, all right? So we're going to try to do that. We're also going to play with a little bit of dimensionality reduction, and so on, all right? So in the next class, so basically all semester we've been doing supervised. If we annotate this and feed it to a model, that would be supervised learning because we have labels. However, we're going to figure out a way to have the algorithm give us the labels. Does that make sense? So instead of manually us assigning the labels, we're gonna force the algorithm to give us the labels automatically. That, of course, is not supervised learning because the only input to the algorithm is X, no labels, right? So instead of supervised learning, that is called unsupervised learning. And usually the algorithm for that is clustering. So that's the one that we're going to explore next week. Got it? All right, perfect. So we're going to stop here for today. And just be aware there will be a new homework assignment as I described. So 5, you need to create the plots that I showed how to create today. You need to collect 5 websites and then 5 RSS feeds. And then the data, remember, you need to clean it so that when I see the picture, I need to be able to read the words. So make the pictures big. It needs to semantically make sense. Is that clear? It should be a pretty easy homework. All right, so let's go ahead and stop the video for today.